See, this is my experiment that's working. That's what things are doing well. I've got your as well.
Little fishy.
It's actually working.
Oh, you ruined it, wait.
I did not really.
Go back.
Yeah, actually, if I can help, he's exactly on 0.2. He's so happy with himself.
You know what? I was thinking, I don't want to do an experiment.
Yeah. See, it's working.
Matthew? Yeah? We got stuff floating around.
Yeah, I think that should be copper.
Yeah, I know.
I think that means it's working.
Right, you've got this one up to 0.8 amps.
See? Smell it? No, definitely. Did you stood in duck shit or something like that?
What?
It smells like duck shit. Did you stood it?
No.
Yeah, you did.
No, my shoes are just...
Message.
No, that's just where the black stuff come off.
I can't
It just comes off.
Oh no, it might be this, you know.
electronic one, which is very accurate.
That doesn't smell very nice.
It's cars.
That's probably the closest you're going to get it.
Probably a shampoo.
Yeah, what we got?
Look, see them little things rolling around? Look, on the top.
Wait,
See them?
which is positive, negative?
That should be working now.
That's anode. So that's negative, right?
Wait,
This is
wait.
So that's your positive.
This is positive, yeah. Why?
There is no positive here.
Yeah, this is my positive.
That is
Side.
That was,
Because it's on the anode, it's connected.
where's negative, sorry?
This one.
Is it connected to this?
No, because that
No,
one...
this one
Mm-hmm.
is connected to nothing.
Sir, you started wrong one. Just,
No, wait.
wait, there's no negative in this.
Oh yeah, that's why.
Yeah, there's no negative here.
That's what I thought, because that is a positive, but it should connect to that and to one of these.
We don't have any negative.
It's actually connected
So
to
we
that.
haven't got any negative.
This one's
Of course you've got a negative. That one's got, that's your positive.
Yeah,
Right, so that's your anode, and this one's got to be your negative.
but this
Well, that's
connects
on
to
the
the positive.
That really doesn't matter there, because it's what's running through it. There's your negative there, it goes through, that's negative, and that's positive.
Oh.
You can't have a complete circuit and one of them's not negative and one of them's not positive. You can't say I've only got a positive, not a negative.
Oh yeah.
It's that determines what's a negative.
But is it hurt if I like change those two?
No, because then you're going to change the polarity. If you change them two, well, that then becomes an anode and that becomes a cathode.
Oh yeah, that makes sense. You can't change it halfway through. You actually...
But that was still like. That was still negative.
And that's negative, and it's going through there. You're getting your reading, and then it's electrons are going through there. That's a cathode, and that's an anode.
Yeah, because
Yeah,
the
but
positive doesn't have to go
it's
through.
like if I change those two around, but it's still negative from here, so this is still cathode, isn't it?
Right, and then what you won't do is you won't get a reading on that. It'll go straight up there.
What do you mean?
If you change them two around,
Yeah.
Then you won't have connection with that.
you will have a connection. But that, right, change it around and watch what happens. That will just stick on zero.
Turn it on.
It is on.
Alright.
Because the electrons are forcing the other way through there. But if you turn it on, put it the other way, you'll get a reading.
Zero.
I shouldn't change it, I shouldn't change it.
We go back now.
So it starts to fall. It starts to fall.
Not too much.
See, that's where you are.
I'm actually mixing cables.
Right, you'll have to hold this now.
Yeah, that's fine.
Right.
So that one's your cathode and that one's your anode.
Still rising.
It's always good when 0.1. Keeps going back.
Are you talking to him?
Stop there, don't you dare to rise.
As soon as you go to that, it goes back to 0.6. Shannon, since you're working with us now, you can hold it a bit.
Oh.
We need like a sellotape.
I was supposed to soothe the microwave company, but not telling her not to look at it.
We started at 25 minutes.
Oh, yeah.
Not 100.
But it's still not. Well, it has worked to some degree. Some of them, man.
I can crack it.
Like, you know, and how big. Supposed to be McDonald's.
Hello.
Yeah. Don't steal my iPhone.
Haha, I just did.
I actually hate you. You stole my iPhone.
I'm in the
I'm
video.
charging you with theft.
Hello.
Okay, this is a not very well known species called the tamas.
You're a tall person.
No. What? I didn't tell Olivia. I said that. What's your second name? Called the Tamasian alcrocias, which is its Latin name, and it's not very found, and it's quite a odd creature.
It's an unaggressive species.
I'm only leaving you embarrassed.
Dinosaurus, what are you on about?
Okay. Oh my god, I'm being attacked by that living Brontosaurus.
Give me that. There we go. I'll focus your mind. Is it recording? It is recording. Ah, yes, it is recording. How do you feel now that it's been confiscated because you've not focused on your work?
A bit guilty on Shannon.
Why is this Shannon's? Right, tough, she shouldn't have given you. Right, what's happening? What's happening in... Oh, well, thou shalt not steal. What's happening in that beaker?
The positive anode, is dissolving. No, it is.
Yes, dissolving.
No, it's dissolving. And then all those dissolving become discharged.
Why is it dissolving?
Because the copper in it's discharging it. So as it becomes discharged and as it becomes unionized or whatever you call it, it dissolves.
So what's causing it to discharge?
The copper. Okay, let me help you out here. I think I'm not too sure.
You think it's a what?
The copper sulfate, because that copper mixed with the copper sulfate, it will have the same amount of ions in them, because the copper with the ions, then it collects an ion from the copper sulfate, or the copper collects an ion from the sulfate collects an ion from the copper, I don't know, and it takes it into the copper sulfate where it dissolves, and then it collects on the cathode, where it picks up an ion or loses an ion. Loses it, picks it up.
Doesn't pick up an ion.
It loses it. An electron.
Picks up electrons at the cathode.
Yeah.
Cathode. So what's happening at the anode?
Dissolving.
Why?
Because it's losing and then electron.
That's correct. You're losing electrons at the anode. Right, you're losing electrons at the anode. They're donating the electrons there. That's going into the circuit. So that's negative there. They then dissolve, go into the
And we get negatively charged.
Yeah, no, they're positively
Oh yeah, and then
charged.
get discharged at the cathode.
Right. That's what I was saying to you at the beginning of the lesson, to make sure you focus and you understand the signs, what's happening in the beaker. Not walking around, drinking drinks, eating your breakfast, and generally being... Yes. So think about the science, what's going on in there.
It was thin off.